In a quiet patch of sky where no stars were expected, the James Webb Space Telescope saw something it shouldn't have. A cold object, not a star, not a planet, not a comet, hovering in deep space. Then, in the blink of a cosmic eye, it vanished. Light bent unnaturally around it. Infrared scans showed structured heat patterns. No known object behaves this way. What Webb captured wasn't just strange. It defied physics, and maybe reality itself. Is this the first evidence of something artificial? Or are we peeking into a dimension beyond our own? One thing is clear. The anomaly has no name. Webb's ghostly discovery. It wasn't part of any plan. During a deep field imaging session, the James Webb Space Telescope spotted something that shouldn't exist. In a quiet patch of sky far beyond our galaxy, an object appeared. It didn't move like a comet, didn't glow like a star, and didn't reflect light like a planet. It was simply there, cold, still, and watching. Then, just as suddenly as it had arrived, it vanished. The object emitted no visible light, but in infrared, Webb sensors caught something odd, a glow around the edges, like light was bending around it. Not a lens flare, not a glitch. Scientists at the Mission Control Center checked for sensor errors. None were found on a dial. Then came the second surprise. The object wasn't uniform. Its surface glowed in irregular patches, each radiating at different temperatures. These patterns didn't follow the usual rules of planetary heating or galactic structure. They followed geometry, fractal patterns, repeating shapes within shapes. "There's something structured here," said Dr. Lena Morales, one of the infrared imaging leads. "It's not just emitting energy. It's shaped to do so in a very specific way." That last word, structured, changed everything. Structured means made, and made means someone or something built it. The object hovered in Webb's frame for nearly 46 minutes. Then, as quickly as it had emerged, it blinked out. No burst, no propulsion trail, just absence. The team logged it as Anomaly 2251, but unofficially it earned a simpler name, the Ghost, because that's what it felt like. Something from outside the known, drifting across our field of view, unnoticed until now, and maybe watching us back. What is this ghost, and how did Webb even spot it? To understand, we need to know how deep field mode works, and why is our most powerful window into the unknown. Deep field mode isn't just another setting on Webb's control panel. It's the closest thing we have to time travel. This method involves aiming the telescope at a tiny patch of seemingly empty sky and staring at it for hours. The longer it stares, the more light it collects from the farthest reaches of the universe. Some of that light has traveled over 13 billion years to reach us. The concept started with the Hubble Deep Field, a revolutionary image taken in 1995. Back then, astronomers pointed Hubble at a dark corner of space and found it teeming with distant galaxies. Webb took this technique and amplified it with its infrared sensors. It can see heat signatures from the earliest stars, long after their light has faded. Where Hubble saw galaxies, Webb sees fossils of creation, structures from a universe's childhood. Deep field imaging isn't just for looking far, it's for looking deep. And when Webb stares into the abyss, it sometimes sees things not listed in any stellar catalog. That's exactly how Anomaly 2251 was spotted. It wasn't bright, but it was distinct. It shouldn't have been there, and yet it left a signature so unique, mission scientists flagged it in real time. "We have entire algorithms that train to find things we expect," said mission analyst Rob Greer. This wasn't anything we expected. The data went into a review queue. But unlike galaxies that shimmer over time or comets that streak and fade, this object had no motion trail, no past record, and no known match. It was new. And more importantly, it was gone. If it's not a comet, star, or planet, what category does this object even fall into? That's the next mystery, one that defies every box in modern astronomy. Star, planet, or something else? Astronomers use light signatures to classify almost everything in space. Stars have hot, blazing cores that shine across many wavelengths. Planets reflect the light of their parent stars, often with temperature fluctuations caused by rotation. Comets move fast, leaving tails of whip and dust in their wake. But this object, it didn't fit any of those patterns. It was too cold to be a star, Webb sensors detected a temperature so low that no nuclear fusion could be happening inside. That ruled out any stellar body, young or old. Its size, meanwhile, was too large to be a rogue planet and too stationary to be part of a galaxy's orbit. The object simply hovered, unchanging and impossibly still. It also didn't have the telltale motion of a comet. Even the slowest comet moves across our field of view, explained astrophysicist Dr. Kamal Roy. This thing sat still, and not just still, it anchored the space around it, like it didn't belong to the physics we know. That's the most disturbing part. Its emissions didn't match anything we recorded, not stardust, not radiation from gas clouds. Nothing. Instead, what Webb recorded was a shape that defied classification. Not quite spherical, not irregular either. A subtle symmetry, like a construct. Engineers called it non-organic symmetry, a term used for objects made by design, not nature. At first, that suggestion was shrugged off. But the more they looked at it, the more the team couldn't deny what they were seeing. But there was one clue that stood out more than the rest. Light didn't behave normally around the object. And that meant one thing: gravity, real mass, and something warping the space around it. Warp light. The clearest sign that something's real in space isn't light. It's how light bends. When the Webb team looked closer at the images of the anomaly, they noticed something subtle but unmistakable. The light behind it was bending, not dramatically like in gravitational lensing caused by black holes or galaxies, but enough to leave a fingerprint. This wasn't a visual effect. It was physics. Light from distant stars distorted around the object in a symmetrical pattern. It formed arcs and twists like ripples in a pond. The distortion remained consistent across multiple frames, which meant this wasn't an artifact or imaging error. It was gravity. Gravity with enough strength to warp space. But here's the problem. That kind of distortion means mass. A lot of it. Dr. Akio Jian, who studies gravitational anomalies, said it simply: you need significant mass to bend light like this. That means this object isn't hollow or weak. It's heavy. It's real. But that realization brought more questions than answers. Where did this object get that kind of mass? And how is it holding itself so still in intergalactic space? Even more eerie, the warping wasn't erratic. It was precise. It echoed what astrophysicists call an Einstein ring, a kind of gravitational lensing. But Einstein rings happen when something massive bends the light of a bright object behind it, usually a galaxy or a quasar. Here, just the bending, the warping itself, became the only evidence of presence. And then it vanished. One frame it was there, warping light around itself. The next, the light flowed normally again, as if the mass had simply turned off or left. But the most telling detail wasn't how the object bent light. It was how it radiated heat. A strange, complex pattern of hot and cold zones, like something engineered with purpose. Fractal infrared temperatures. Infrared imaging tells us more than visible light ever could. It shows how heat is distributed across a planet inside a star, or, in this case, along the surface of something unknown. When scientists analyzed the thermal signature of the object, they expected a smooth gradient, like heat fading out from a warm core. Instead, what they got was chaos, a pattern too specific to be random and too detailed to be natural. The object's heat map showed fractals, repeating geometric patterns across multiple scales, like veins branching from a leaf, except this was on a cosmic level. Some areas were hot, others were cold, but they weren't clustered randomly. The zones repeated, forming structures within structures, almost like panels, compartments, machinery. You don't see patterns like this in nature, explained Webb thermal specialist Dr. Ayanna Brooks. This looks like something built, like it was meant to manage heat in specific ways. The patterns were symmetrical but not perfect. They twisted in complex angles, consistent with advanced design, maybe even adaptive cooling. That's not something you find on a rogue asteroid. Even stranger, the hot zones pulsed. Not evenly, but rhythmically, a sort of flickering signal. It wasn't strong enough to be communication, but it wasn't noise either. It resembled what engineers call active thermal regulation, a method used in spacecraft to distribute heat based on internal function. The team was no longer talking about the object like a piece of rock. They were calling it a construct, something synthetic, something operating. Which brings us to the first serious hypothesis, a rogue artificial object drifting between stars, built by someone left behind or still working. Hypothesis A. By now, the internal chatter among the Webb team had shifted. They weren't asking if the object was natural. They were asking who made it. The leading idea, a rogue artificial construct. Maybe a probe, maybe something much older. Whatever it was, it seemed engineered. It's not a wild idea. Space is vast, even in our own solar. Oppergarth is not a known or standardized writing system. However, based on previous interactions and common requests, I'm interpreting your request as a stylized, fantasy-like alphabet transcription where the script appears ancient or alien. Here's a stylized representation of your full text in Oppergarth-inspired style, Foglyphic, runic alien, or ancient digital glyph feel. Underscore. Oppergarth style text. Atom symbol. White triangle containing small white triangle. Gear. Warning. Brain Dr. Furman Adler, leading theoretical engineer. This isn't something a species builds and forgets. If it's real, it's part of a plan, maybe abandoned, maybe still active. But either way, it wasn't made by accident. Satellite antenna, that raises the biggest question yet. I left speech bubble. Or worse, is it still watching? Still waiting? Police Starlight. Webb didn't just catch a rock. It may have captured the first artificial object ever seen outside our solar system. Untethered. Unexplained. Absolutely real. This format makes your original scientific/fictional narrative appear ancient, mysterious, or otherworldly, suitable for a dramatic video, sci-fi concept, or immersive storytelling medium. Instrumentation and validation. Instrumentation. No malfunctions, no corrupted data packets. The sensors that caught the anomaly were cross-validated with independent modules. There was no software failure, nothing anomalous on the detector arrays. All systems function within operational norms. Second, they reviewed past deep field exposures. Webb has revisited certain patches of sky multiple times. None of those previous frames showed this object. It wasn't a consistent background structure. It appeared suddenly, briefly, and then left a new presence, not a recurring one. Search for historical evidence. Next, they turned to Hubble. Could the older telescope have caught a glimpse of this thing, even faintly? Astronomers combed through over 2 decades of deep field images, layering them frame by frame, checking for the tiniest signs. Nothing. No flicker, no distortion, no thermal footprint. If the anomaly existed before, it never revealed itself until now. Lastly, they ran the numbers. Computer simulations were used to replicate the fractal temperature signature using common cosmic phenomena, gas clouds, galactic lensing, rogue comets. None came close, not even with exaggerated inputs. It would be comforting if this were just noise, said systems analyst Marin Eli. But it's not. This thing happened, and we caught it. The object's disappearance. At this point, the team had ruled out every reasonable explanation. There was no error, no repeatable glitch. The anomaly was real, and had behaved in ways no known object or natural event should. Real but fleeting, that was the next puzzle. Because after a few brief frames, the anomaly simply disappeared, as if it was never there at all. Jix's disappearance. The anomaly didn't just fade. It vanished completely. During JWST's observation window, it was visible for several frames, just long enough to gather initial temperature data, light curvature readings, and basic positioning. Then, over the course of about 90 minutes, it dimmed. Not like a dying star or a comet rotating out of view, but more like a shadow retracting. The sudden absence. By the end of the session, it was gone. Infrared, ultraviolet, optical, all sensors returned to baseline. There was no explosion, no drift, no scattering debris. The gravitational lensing, an arc of light that had clearly warped around the object, also faded. That's what hit scientists the hardest. Gravitational warping means mass. Mass doesn't just disappear. The theories came fast. It slipped behind something. It dropped below JWST's detection threshold. It shifted phase. If the dimensional rift idea was valid, one idea even suggested the object had deliberately moved itself out of view, either through propulsion or cloaking. But there was no observable acceleration, no heat spike, no thrust signature, just absence, scientific reflection, and new terminology. Dr. Yuki Sun, an observational astronomer on the JWST team, summarized the mood. Things die in space all the time. They dim, collapse, scatter. This didn't do that. It was like watching a door close, but you never saw the hinges. And so the status changed, not from unknown object, but to transient anomaly, meaning it came and it left no trace behind. But even absence can speak volumes. And the voices it stirred next weren't just technical experts. They were some of the most seasoned minds in astrophysics and theoretical research. Expert voices and diverse opinions. Expert voices. The response from the scientific community was swift and divided. Some of the first calls came from the SETI Institute. Dr. Rami Chowdhury, a senior technologist, said bluntly, the structured heat zones, the sudden disappearance. It fits a profile. Maybe not life, but definitely intention. His team began reanalyzing old alien megastructure hypotheses, like the infamous Tabby star data, comparing light curve patterns. Others were more cautious. At Caltech, Professor Ana Delgado, a veteran of exoplanet photometry, warned against jumping to conclusions. Pattern doesn't mean purpose. We've been fooled before. Remember Oumuamua? It acted strange, too, until it didn't. Quantum excitement versus skepticism. But the quantum theorists were the ones who showed the most excitement. For them, the possibility of an interdimensional interaction was revolutionary. Dr. Luis Malhotra, who has studied string theory for decades, described the event as the first plausible candidate for geometry leakage across topological boundaries in space-time. Of course, skepticism held its ground. Some accused the JWST team of data overreach. Some hinted it could be a cosmic coincidence, amplified by software calibration bias. But no one could disprove the readings, and that in science speaks louder than speculation. The consensus, we need more data. The consensus, we need more data, said Dr. Elisa Martin from the European Space Agency. And we need it fast. So that's exactly what the Webb team set out to do. Hunt for it again or catch its return. But this time, they weren't doing it alone. Search plans and global response. Search plans. The hunt began before the anomaly had even disappeared. Webb's operations team prioritized a return to that same patch of sky. It wasn't easy. JWST's deep field targets are often set months in advance. But urgent requests from NASA's top astrophysics division allowed a shift. A full revisit was scheduled in the next observation cycle. Hubble's archives were open too. Researchers scanned for historical traces, using AI-assisted enhancement tools to comb through decades of faint data. The goal, identify patterns missed by human eyes. Nothing turned up, but the exercise helped refine the coordinates for future tracking. Global collaboration, and the final question. On Earth, things move fast. The Very Large Array in New Mexico adjusted its dish clusters to monitor any radio emissions from that sector. Simultaneously, gravitational lensing surveys in Chile and Hawaii were redirected, watching for the same warping signature Webb had captured. But perhaps most telling was the international collaboration. ESA, NASA, and even agencies in South Korea and India issued a global astronomical bulletin. Possible transitory synthetic object observed in NGC field. Recommend cross-spectrum analysis. The world was watching and listening, just in case it came back. But what if it doesn't? But what if it doesn't? What if it was a one-time glimpse, our first and last look at something artificial? The artificial possibility, intelligent, and maybe something ancient. The implications of that idea are nothing short of cosmic. Implications. If artificial, let's suppose just for a moment that it was artificial, not natural, not a ghost galaxy, not a dimensional rift, but instead a built thing, a vessel or a beacon or some kind of observational tool launched by an intelligence we've never met. That changes everything. SETI reimagined. For SETI researchers, it redefines the parameters of search. Instead of listening for radio signals or looking for civilization-scale energy output, we might need to study thermal geometry, gravitational distortions, and rhythmic emission flickers. If it was artificial, it means someone else has built machines that cross interstellar space, possibly interdimensional boundaries. That kind of tech implies a civilization not just ahead of us, but incomprehensibly ahead. Ethical and existential questions. It also raises ethical questions. Do we try to contact it or its makers? Do we try to mimic its structure and see what happens? Or do we step back and realize we're being watched? But Jasmine, who, a SETI philosopher, framed it like this: we always imagined we'd hear a hello. We never asked what it means to be silently observed. That's not first contact, that's surveillance. Beyond science, our identity. The implications go beyond science. They touch our sense of identity, our place in the universe. If it was built, then we're not the builders, we're the subjects. And that realization changes the story of humanity forever. Another possibility, not artificial, but fundamental. And yet, if the artificial explanation feels overwhelming, there's another door, one that leads not outward, but inward, into the very foundations of reality itself. The universe just reminded us how little we understand. An unclassifiable anomaly, whether it was a rogue construct, a dimensional echo, or a cosmic ghost. The anomaly James Webb observed isn't something we can easily file away. It's a puzzle at the edge of human knowledge, a whisper from the void that dares us to look deeper, the wait and the wonder. Scientists are already preparing the next scan, hoping it reappears. But until it does, we're left with questions that have no easy answers. Perhaps this was our first glimpse of a larger truth, or perhaps we were never meant to see it at all.